Have you ever wondered how robots manage to move so precisely through their environment, whether it is a factory floor or outer space? What allows a robot arm to reach out and delicately pick up an object, or a mobile robot to navigate a room, seemingly with limitless freedom? Translational Degrees of Freedom, often abbreviated as Translational DOF, directly refer to a robot's ability to move along an axis without changing its orientation. Simply put, it describes a robot's capacity for pure linear movement within three-dimensional space. The core concept here is about independent axes of motion. In our three-dimensional world, there are three primary axes along which an object can move linearly: forward and backward, typically called the x-axis, left and right, known as the y-axis, and up and down, which is the z-axis. Each of these represents one distinct translational degree of freedom. A robot possessing all three translational DOF can theoretically position its end effector or base at any point within its operational workspace, without needing to rotate. Robot engineers and designers meticulously consider translational DOF when conceptualizing and building robotic systems. For instance, a simple automated guided vehicle, or a GV, moving on a flat factory floor might only requiring to translational DOF along the X and Y axes to navigate. However, a sophisticated robotic arm designed to perform intricate assembly tasks or surgical procedures absolutely needs all three translational DOF to precisely position its gripper or tool at the exact point in space where it needs to operate. This fundamental understanding guides the selection of appropriate joints and the overall mechanical design of a robot. This capability is intrinsically linked to the concept of Cartesian space, where every point in an environment is uniquely defined by its x, y, and z coordinates. Translational DOF directly quantifies a robot's capacity to navigate or position itself within this coordinate system. It is also a critical distinction from rotational degrees of freedom, which describe a robot's ability to rotate around an axis. Together, these two types of DOF form the basis of a robot's kinematics, which is the study of motion without considering the forces causing it. Therefore, grasping the concept of translational degrees of freedom is foundational to understanding how robots achieve accurate positioning and perform essential tasks. It is the bedrock that allows robots to move efficiently and effectively, enabling them to bring their tools and sensors to specific locations in their environment for complex operations and precise interactions.
If you love robotics, like, subscribe, and keep building with us.